everyone. A store has been selling PlayStations each week at $3.50 each. The market survey indicates that for every $10 rebate offered to its buyers, the number of units sold will increase by 20 a week. We're going to find the demand function and the revenue function, and then determine how large a rebate should the store offer to maximize its revenue. So I wanted to go over real quick the vocabulary needed for this problem. So basically this is an optimization problem, and we're using marginal cost, revenue, and profit functions to minimize costs and maximize. We want to minimize the cost and maximize revenues and profits. So basically, instead of me reading all this, you might want to screenshot it. This will help you with your optimization problems when it comes to applications to business and economics. All right, and we're going to be using this one. We already used the cost function in earlier videos, and also the marginal cost function. So we're starting to add this to what we already knew. So here's our problem. And we know that if X is the number of PlayStations sold per week, then the increase in sales is going to be X minus your $10 rebate times 20. So that's going to be 10 times 20, because you have to subtract that out of your number of PlayStations sold. So that's going to be X minus 200. All right. For each increase of 20 units sold, the price is decreased by $10. So that's why we get that. Also, so for each additional unit sold, the decrease in price will be 1 divided by 20 times 10, just equal to 10 divided by 20. So for our demand function, we're going to write this as P of X equals your total price. So that's going to be, we're using the P of X, the total revenue. So that's going to be $3.50. That's where we're starting, minus this times, what did I put pi? 10 divided by 20 times your weekly increase in sales. So that's going to be X minus 200. Now simplifying this, we're going to get 350 minus 1/2 times X minus 200, which equals 350, minus 1/2 X plus 100. And distribute that. So it's going to be 450 minus 1/2 X. All right. Now, the revenue function formula, so that's this is going to be this one right here, is R of X equals X times your profit function, or your price per unit. All right. So, for example, if we had 100 units and it was $5, that would be this. Well, so we're going to write R of X equals X times our profit function, and that's going to be 450 minus 1/2 X. Now distribute that, and we get 450X minus 1/2 X squared. All right, so now we're going to do our marginal revenue function. That is the rate of change of revenue with respect to the number of units sold. So when you take your r prime of x, you're going to get 450 minus x. Set that to 0, and you get x equals 450. So this value of x gives the absolute maximum. Okay, by the first derivative test. Or you could also look at the graph and see that the parabola opens downward. So therefore, the corresponding price is going to be P of 450, because that's the total max, then equals 450 minus 1/2 of 450, and that equals 225. Now the rebate is going to be 350 minus 225, and that equals 125. So to maximize revenue, the store should offer a rebate of $125. And that's it. Thank you. Have a nice day. Bye-bye.